Good morning, students. Once again, this is our third class of our +1 physics syllabus. Now, today in that class, we will study about physical quantity. In practical life, our main physics starts from that term that is called physical quantity. Now, you have to understand very carefully how will you design and base and foundation for our higher material +1 physics. Now, first of all, we have to understand physical quantities. Since in our society there are lots of things, living and non-living things, in which some can be seen to our eyes and some cannot be seen to our eyes. But main common thing in that, some are measured. So, in simple words, we can say that all those quantities used to represent law of physics, means वो सभी क्वांटिटी जो फिजिक्स के लॉ को रिप्रेजेंट करते, देयर आर मेनी लॉज इन आवर फिजिक्स और विच कैन बी मेजर्ड, जिनको मेजर्ड किया जा सकता है. फॉर एन एग्जांपल, suppose if I took a word rice, then that rice can be purchased from market by measuring in that manner 1.5 kg, 3/2 kg, or it may be 1 kg, or it may be 1000 gram. So in that manner we can say that all those physical quantity in our nature which are measured and used to represent laws of physics are commonly referred as physical quantity. Now, in physics, every physical quantity represented by that symbol Q is equal to Nu, where Q is actually the symbol of any physical quantity. It may be mass, length, temperature, velocity, force, density. There are lots of physical quantity in our physics syllabus, and n is a numerical value. That numerical value may be in decimal, may be in real number, or may be in fractional. All three categories are included inside that numerical value, and U is called unit. The unit is that level in which that physical quantity is measured in our society. So we can say that every physical quantity in physics represented by that symbol Q is equal to Nu. Now that physical quantity classified into two main categories. First one based on direction property, and second one based on their dependency. If we try to classify based on their direction property, then these physical quantity in our nature in two categories. First is scalar, second is vector. Scalars by its name just have magnitude, not direction. Those quantity which have some value but don't show any direction, just like mass, length, volume. Just let mass can be measured, just like rice can be measured, but does not have any direction. That's why it is called scalar. While those physical quantity which have magnitude as well as a direction, and obey law of algebra, means this quantity can be added also, subtract also, etc. all these, and product also. So in that manner we can say that vector are those quantity which have magnitude as well as direction and obey laws of algebra. For an example, displacement, force, velocity, that terms are very common and we have already studied in lower classes. Now on the property, on the dependency, there are also two classifications. First is fundamental, or it may be commonly called base units, and second one is derived quantity. Fundamental or base quantities, those quantities which do not depend on other terms. For example, mass, length and time. Actually, this is the very smallest quantity. You can't break it. These are the simplest. For example, if I took a word force in physics, since we know force, mass and torque, acceleration. But acceleration in lower classes we have studied velocity by time, but velocity displacement upon time. Then there is mass, displacement and time into time, means mass, displacement and time तीनों मिलेंगे, collectively combine and make a special term in our physics that is called force. So it is clear that this quantity is derived from these main base units. That's why this quantity are referred as derived quantities. So derived quantity definition will be those quantities which depend on other. Other stands for base units. There are only three in our society: mass, length, and time. Or it may be expressed in these terms: mass, length, time. In that example, we are saying these can be represented like that: mass, length, and time. Basically, length and displacement are same. You will understand in kinematics unit. Now, there is another four types also of quantities. Some quantities are dimensionless and some are non-dimensionless. But that quantity we will study as we pass in physics and we spend lots of time in physics. Then some important or main common terms generally come in our study areas. And similarly, some quantities are constant and some quantity can be changed according to environment. That's why these are variable also. In that manner, this was all about your physical quantity representation and their classification on their dependency property and other areas. Now, next question is unit. What is unit? Unit, as I told you, unit is the base or a level in which physical quantity can be represented. That means a unit is a standard level of measurement of a physical quantity. Means anything, any physical quantity can be expressed in any level. That standard level is called a unit. For example, if I took rice, but rice in physics it is a mass, but scientifically, then mass have a unit: gram, kg, quintal, etc. All these. So we can say rice is equal to 1.5 kg. In that manner, if I write the list to purchase something from market, that means I follow the scientific rule to represent the physical quantity according to physics point of view. So these are the units and some examples where we can understand how units are represented in a different standards to measure any physical quantity. Now, what are the characteristics? There are the main common 5 characteristics generally observed in any quantity. First one is well defined. Every unit of physical quantity should be well defined. For an example, if we want to purchase 1 kg, that means it should be equal to 100 gram. But 1 kg is a suitable amount. 1.1 and 9.99.9 gram is very small. Is very slightly small than 1 kg, but it is not equal to completely 1 kg. That's why we can say that every unit should be well defined. Second, it should have a suitable size because 1 gram is equal to 1000 gram. 1000 ग्राम मिला के 1 ग्राम बनेगा, 1 kg बनेगा. That's why we can कह सकते हैं कि it is a suitable size. Third one is universally accepted, means those physical quantity which use a particular unit, that unit should be famous all over the universe, means overseas, means India, Pakistan, etc. all the other countries. There are the 192 countries in our world. Every country know that what is kg. That is the first main thing. These are the 3 main characteristics. Fourth one will be reproducibility. That means kg can be converted into gram and kg can be joined into quintal and quintal can be converted into milligram, etc. In that manner you can change system to system. This is called reproducibility. While fifth one is convenience in use, means every unit should be very easy and understood by other person also. That is the convenient in use. For an example, if I demand rice 5 kg, then 5 kg measured by easily one that know the basic units of measurement. In that manner, we can say it is should be conveniently used. These five quality always possessed by a particular unit, and that unit is basically standard level of measurement of a physical quantity. So we can say that unit and unit characteristics. That was all our question answer. Now next is system. This is important. System is a set of arrangement in which units of fundamental quantity. Here, how many fundamental quantity? You just tell there are three main fundamental: mass, length, and time. These three fundamental quantity are arranged in such a way their units are assigned by a system. That system. How many system? There are four main system in physics. First one is foot, pound, second. That system is basically used in British system, that is in England. While in this one CGS, its complete name is centimeter gram second, and MK stand for meter kilogram second, and last one is SI, that is called System International, or its other name is Advanced MKS, means Advanced MKS system. So in that manner, systems are classified into four main categories, which are FPS, CGS, MKS, and System International. Now, how use this system? Let us see. Since there are three main fundamental units or quantity: length, mass, and time. This is unit, or it may be called fundamental quantity, because length, mass, and time are fundamental quantity, but their unit is different. It is meter, it is kilogram, it is second. But we are not taking a unit here, we are taking unit fundamental quantity. Then you have to write here quantities. Now, F for foot. In case of FPS, length is measured in foot, but in case of CGS, it is measured in centimeter, but in case of MKS, it is measured in meter. Similarly, pound, mass is measured in pound in case of MKS, and in gram in case of CGS, or in kilogram in case of MKS. Similarly, time. Time is a special fundamental quantity which have common unit in all the system. That keep in mind. Important thing. While length and mass change their unit from system to system. Now, last one that we will discuss, System International. Very crucial. System internationally classified into two main categories: fundamental and supplementary. In fundamental, we have know that there are already base three units: mass, length, and time, and it will be discussed in MK system. But it is advanced version, means there are some important terms also added. These four terms are this one: current, I stands for current, temperature, second luminous intensity, and fourth one amount of matter. Now these four special terms added and three already from MKS. That means it is advanced MKS which completely combine and make a fundamental unit. In that system, SI system, is there are how many fundamental quantity? 4 and 3, 7 fundamental quantity in fundamentals. Point to be noted. Second, in case of supplementary, there are only two physical quantity: plane angle and solid angle. And these plane angle and solid angle combined together makes